Hello to all physicists old and young. My name is Ian Bell and I will be teaching about wave-particle duality today. As a prerequisite, I suggest learning more about waves and how they interfere with each other before watching this video. We'll be talking about the wave-particle duality in the double slit experiment by Thomas Young, Einstein's special relativity paper, and his photoelectric effect analysis, as well as another double slit experiment done by Geoffrey Taylor. And then we'll talk about the wave-particle duality that's in all objects, as well as implications and application of wave-particle duality in quantum mechanics and in our everyday lives. First, though, let's go back, time travel back to 1801 to Thomas Young and his double slit experiment. Thomas Young was in favor of the idea that light was a wave. He wanted to see what happened when a light beam was shot through two tiny slits. As he shot the light through the slits, something strange happened. Light showed as an interference pattern at a screen behind the two tiny slits, as if it was a wave. Young's idea that light acted as a wave were generally accepted in the late 18th century until another experiment came along. In 1906, Einstein postulated that light are packets, or bundles of quantized particles called photons. When these photons were shot at a metal plate at a certain frequency, electrons were emitted from the plate. This did not adhere to Maxwell's electromagnetic wave theory of light. Wave theory suggests that light at any frequency should eject electrons. However, electron emission occurred only for frequencies larger than a certain frequency. According to the wave theory, since energy depends on intensity, the lower intensity light must produce electrons after enough time so that the electrons can acquire adequate energy to get emitted. However, electron emission was immediate no matter how small the intensity of light in Einstein's photoelectric effect experiment. Since light is bundled up into photons, Einstein stated that when a photon falls on the surface of a metal, the entire photon's energy is transferred to the electron. But the question remained, why can light act as both a wave and a particle? Einstein's theory was proved in 1908 when Geoffrey Ingram Taylor conducted the double slit experiment, again, but this time by shooting only one photon through the slits at a time. After enough photons hit the screen behind the slits, an interference pattern was still seen, as Young proved in 1801. But when Taylor tracked the individual photons, something odd happened. The monitored photons acted as particles when individually observed. The photons abandoned their wave-like state and went back to acting like a particle, even though the interference pattern still showed up on the screen. It's like those photons knew they were being watched. Even today, the question on wave duality is still debated. The double slit experiment has been done many times, even with different particles such as electrons, atoms, and macromolecules. We know now that not only light, which is a massless particle, but even things with mass show both wave-like and particle-like properties. So all objects have duality, even you and me. Physicists like Einstein and Taylor changed the way we look at the world almost overnight. The wave-particle duality principle has set the foundation for quantum mechanics, which now influences our everyday life. The implications are huge. This redefined how we look at the world. That classical mechanics, Newtonian mechanics, are not true in all situations in the universe, especially at the subatomic level. Because of quantum mechanics, we have super powerful computers that fit in our pockets, or phones. In fact, quantum mechanics is the foundation for the whole computer industry. Semiconductors, like the ones in our phones and laptops, depend on the band structure of solid objects. This is also a quantum phenomenon, depending on the wave nature of electrons, and we can manipulate the electrical properties of silicon. GPS, MRIs, atomic clocks, fiber optics, telecommunications, and even the internet all use quantum theory for them to work. Quantum mechanics is huge, and wave-particle duality, was the start of the quantum era. Thank you for all your time and attention today. I hope you learned a lot about wave-particle duality, and I hope you have a great day. Thanks.